All right, so how are we doing? We're good.
Good.
All right, let's bring up this now.
This is 8:45. Yes, that. When I
No,
start.
all right, let's start now. Remember, we are always on time, right?
Yes, sir.
Yeah, we're always on time. We mean business. All right, so um, we'll just do a quick run through. We are ahead of schedule, right? We're ahead of the plan, so we don't have to go that quick this morning. We can clear up anything from yesterday. Um, somebody want to tell me what scalar quantity is? What is a scalar quantity?
So we focus it only on distance.
Yeah, it focuses only on size, right? Only on size.
Oh,
Yeah,
wrong song maybe.
yeah, man. And then the what is
Vector.
a vector quantity? What is a vector quantity? It
The one
focuses
the
on,
focus points.
yeah. Go ahead.
Scan.
Distance or length, sir.
It focuses on size,
Focus is on direction.
size and direction. Right, right. Perfect, perfect. Good. All right, so we're good with that in that regard. Right, so focus on size and then vector quantity. This is supposed to be a vector quantity. I need to change this.
Answer.
Focus on size and direction. Question? I hear a question. All right, let's move on. So we did this already. Distance describes the amount of space between 2 points or the amount of ground covered by an object. Displacement describes the amount of space between an object in a direction, right? And it is the amount of ground covered by an object in a particular direction. All right, so these are some fundamental things that we need to cover before we go into momentum, right? And speed, right? Which one is the scalar quantity and which one is the vector quantity?
Of a distance and displacement.
For
Momentum is
speed,
vector.
for speed, speed and velocity. Speed is what? Scalar or vector?
Yes, sir.
Alright, come back.
Scalar, right? Speed is scalar, and velocity is scalar or vector.
Vector.
Right. All right. Perfect. So we're on the right track. Um, and we spoke about this yesterday. Just going back through. Um, so for average speed, we have our velocity and we have our time. In order to calculate these, of course, we just transpose. Very simple, right? Now we move to acceleration, right? Acceleration now. Uh, then, right. So acceleration is essentially change in velocity, right? Just a change in velocity. Of course, we let's say that the velocity is at zero, right? Velocity is at zero, and we increase it to to it's at 0 meters per second, and we increase it to 2 meters per second, right? We would accelerate, right? If we are at 2 meters per second and we go down to 0 meters per second, what would you do in this case? Somebody want to give that a try? If we accelerate here, what would you do here? 2 to 0. What would you do? decelerate, right?
Yes, sir.
Yeah,
I'm
decelerate.
never sure. Never sure. That's what I'm gonna say.
That's okay. That's okay.
Never sure.
According to Amazon.com.
Right. So we have accelerate and then we have decelerate. Perfect. Now, the U represents the initial velocity. When I'm uploading the notes, I'm going to make the changes and add in what needs to be added in. Right. Initial velocity. Initial velocity here. This should be initial velocity. Or I could just upload this. Yeah, let me just upload with the writings on it. Probably that will be better for you. All right. And time. This is time. Right. So U is our initial velocity, and V is our final velocity. Right. And T is the time. Right. Okay. So if we say our initial velocity is 0, and our final velocity is 2, and we that is done in say 2 seconds. 2 seconds. So time equal 2 seconds. What would our acceleration be? So right, A equal what?
1.
The acceleration.
V.
Let's just go through. Let's just go through step by step. Right. Let's go back to step by step.
Alright.
What's our final
A
velocity?
equal 2 minus 0
Right.
over 2.
Over 2. So our acceleration will be 1 as a per as some right. I'm going to mute some mics. Right. All right. Good. So yeah, our acceleration. Let's try one more time. Let's say our acceleration is our initial acceleration is 2. So this is U and this is V. Help me out now. What would we have here? A equal what?
0.
0 minus 2. Right. And then this would be 2. So it would be negative 1. So what does the minus mean there?
Minus.
What does the minus mean? You realize there's a
Negative.
negative, which is representing what?
The acceleration.
Deceleration. Yeah, deceleration. So if there's a plus here, it means what? Acceleration.
Acceleration.
Right. And if there's a minus here, it means deceleration.
Deceleration.
Perfect, guys. All right. So one more thing. If we take a look at the units, let's take a look at the units. Now, what is the unit for velocity? You remember that?
Kilometer.
No, meter
Meters.
per second. Right? That's the unit for velocity.
The minus.
And yeah, this is the unit for velocity. Because remember that our formula is V equal S over T. What is the unit for distance? What is the unit for distance? M. Right, so meters. And what is the unit for time?
S.
S. So if you want to move that S into the same line as the M, just to make it more presentable, we would have to put a -1, right? A -1. Yeah, to show that it was in the denominator. Right? So we have our -1 here. So this is our unit for velocity. All right? This is our unit for velocity. Unit. Right? And now we go over to acceleration. Right? We have the difference in velocity here. Right? So we have the initial velocity, we have the final velocity V and the initial velocity U. Right? So the unit up on the top, right? The unit up at the top would be velocity, right? Because it will be the difference. So the unit at the top would be, I'm just write that over again. unit at the top would be meters per second, because that would be meters per second minus meters per second. And then what's the unit for time? Just bear with me for a second. S, right? So if we minus meters per second minus meters per second, that's going to be that it doesn't change. It doesn't change. So it's going to be meters per second over S. Right? I'm just trying to break down I just don't want to give you the unit. I want to show you how you actually get the unit. Right? And you won't necessarily be needed to do this. You just need to remember them. You need to memorize them, but I just want to show you where we're coming from with this. All right. So it is meters per second minus 1 over S. How do we fix this now? We want to make this more presentable. Somebody want to give it a shot? What would this be? If this is ms minus 1, what would it be now?
Is then
If you want to bring up
Sir, gonna cancel out, sir.
no, not going to be cancelled.
no later.
If this is if there was no negative one here, it would be cancelled.
Let us be M.
It's going to be m s minus what? Because we have one more s down here.
2.
S square.
Two.
Yeah, ms minus 2, right? Ms minus 2. So I just want to show you where we're coming from. We understanding this step here?
Yeah.
You want me to go over it again?
Yes, sir.
Go right, sir.
Go over it? All right. So our velocity, our unit for velocity is ms minus 1. And we just show you how we got that from the seconds, right? And you'll be doing this more often when you're doing a gradient, right? We'll be focusing more on units. When you're plotting grades in your labs, when you start doing labs, you'll be focusing more on that. But for now, we just want to show you like where our units are coming from. So we have a velocity at the top. Both of these are velocities. So if we take away, say, let me show. I hear your question.
What you mean again?
U is our initial velocity.
Oh, all right.
Yeah, U is our initial velocity and V is our final velocity, right? This is a question. If we have 2x and then we minus 1x, what would the answer be?
We have 2x minus 1x.
Yeah,
1x.
X.
it would be
X.
1x. So it's the
X.
same thing, right? It doesn't really change. The x is still there, right? The x doesn't change it because they're the same. So if we had 2 ms here minus 1 ms, it would be ms, right? Just don't let it, just remember that.
That doesn't negative come off, right?
Yeah, it is basically the same thing. So we're not going to minus anything, right? Units don't really minus. They only really focus on dividing and multiplying. That's the only time they change. All right. So because we have ms at the top, ms minus 1, and we have s at the s down here, right? Now the ms minus 1 would change to ms minus 2. Why? Because we now have ms m over s times s. Remember that this is our velocity. Remember that?
Yeah.
Velocity. So because we have 2 down here now, it would be ms minus 2. Are we good now? All right. Any questions?
No, sir.
All right. All right. So we already spoke about Newton's 3 laws. Let's just go over it again. It's the first law. There are 3 laws, but we're just focusing on the first one and the second one for now, right? And the first one states that an object that is at rest will stay at rest. So if we have a bottle on the table, it will remain there until we push it. And an object in motion, Go again.
It is stated to apply force.
Yeah, till we apply an external resultant force, right? And an object in motion, it would stay in motion. So if we have a car with no brakes and the road is smooth, the road has oil on it, right? And the car will just continue sliding, just continue sliding. But because we have roughness on the road, it builds up what we spoke about yesterday again. What was that F word
Friction.
again? Friction.
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 Right. So because
Sir, plus the car, them have a grip,
Right.
wheel.
right, so that builds up friction, which helps the car to be able to control its speed much better. Because we don't want, if we never have any grip, we wouldn't be able to slow down. We continue until we crash, right? So, an object at rest will stay at rest, and an object in motion will stay in motion with a uniform velocity. The velocity will never change. So we continue sliding until we apply an external resultant force, which would be, for example, our brake, right? Our brakes on the car. All right. No, remember this word, inertia, right? Inertia. So this is this is the resistance of an object to change its position. So if we have a bottle, as we spoke about, if we have a bottle, right? We have a bottle, right? It will try its best not to move. So if we push it, if we apply a force, say F, if we apply a force to that bottle, if the force is not bigger than the inertia, it will not move, right? So the F has to come bigger than the inertia. It has to be bigger than the inertia for the bottle to move. All right, so very good so far.
Same thing as like when something like bottle.
Yeah. So if we have more stuff in the bottle, say we have some water in the bottle now, the inertia will be greater because, of course, it has a higher weight. It has more mass, so it is harder to move. All right. All right. We're good so far.
Yes, sir.
All right.
Yes,
Good.
sir.
Yes, sir.
All right. So we spoke about Newton's second law also. As I said, we're just recapping. So Newton's second law states that the force is directly proportional to mass times acceleration, right? And we also said that if force increase, what will happen to this?
Acceleration increases.
Right. The mass
These two of
and
them will increase, they walk hand
Yeah.
in hand.
together will increase, right? So if we increase this over that side, this over this side will increase, right? And we said that 1 Newton, which is the unit for force, is the amount of force. That's the amount of force that is required to move 1 kilogram of an object with an acceleration of ms minus 2. We see that ms minus 2 coming up back again. All right, we see that ms minus 2 coming back up again. All right, so we'll now move on, and we stopped here yesterday as it relates to linear momentum. So we said that linear momentum is a term in physics that is used to describe an object with a mass in motion, right? And it is considered a scalar vector,
Huh?
right?
Vector, sir.
Vector.
Right, because of this guy right here, because of velocity, right? So whenever we have a vector quantity in a formula, right, the product of that formula is vector, right? All right, so we spoke about our Lambo, right? Lambo and our Corolla, right?
If for some reason Corolla faster.
Yeah, yeah. For some reason, I don't know. There's something
Some weird
special about
reason.
this, right? Um, Probably it's because it's so happy, right? It's at 35 meters per second. This should be one,
With a mass, huh?
and it has a mass of 1500, and this has a mass of 1000, right? And this is faster than this. So which one would have the greater momentum?
The Corolla.
Yeah, the Corolla is much better than the Lambo as it relates to momentum, right?
Uh-huh.
Yeah, so get yourself a Corolla, right? Uh, so moving on to the other aspect of Newton's second law, right? So we spoke about momentum for a short while, and we just want to understand it first before we move over to applying Newton's second law, because we're going to apply it now, right? No, this guy, no, impulse, impulse. Now, impulse is change in momentum. So impulse equals to change in momentum. All right, before we move on, I'm going to pause and I'm going to bring up something. Before we move on, just have it in your mind that impulse is change in momentum, right? Impulse is change in momentum. Let's bring up this quickly.
Is changing momentum.
Yeah, impulse is a change in momentum.
So it's a vector quantity too.
Yeah, it's a vector quantity, and that's because we have our what involved? We have our velocity involved, right?
Uh-huh.
Let me see if this is coming up. Come on. All right, so I'm going to share my screen now. Message in the chat. Okay. All right, share screen. All right. So, we are here, right? We have our momentum, and we have our mass, our different mass. Now, say we move this. All right, let's leave it there. So we have, all right, that's not gonna help either. We have our mass 0.5, and it would have. I don't know why it's not showing me the. All right. I wanted to show me the values. It's not showing me the values. More data. Right. Okay. So let's move this down here for a second. And we have 1. Let's say 1 is not troubling anybody. Nobody's in the way. Right. And our velocity is at 1 meters per second. Approximately 1 meters per second. So are we seeing this so far? Please let me know.
Yes, sir.
Right.
Yes, sir.
All right. Perfect. So velocity in the x direction. All right. We're not going to complicate things. Right. So it's approximately 1. Right. And it's moving horizontally. Right. Now, if we plate, all right. Let's try that again. Restart and move this out of the way. Right. I'll remove this first one. So let's just go look at the momentum of this ball right here first. Now, mass is 0.5 kilogram, right? I want somebody to calculate this for me now. The mass is 0.5 and we are moving with a velocity of 1. What is our momentum? What is our momentum here?
Mass 0.5.
Momentum of how much?
Yeah, what is our momentum? Remember that momentum is mass times velocity, right? Momentum is mass times velocity. We
Oh,
spoke
sir,
about
wait,
this.
so review. Yes, that's what I was saying.
Yeah, so our mass is 0.5.
0.5.
Right, our mass is 0.5 and our velocity is 1. So our momentum would be 0.5, right?
0.5.
Yeah, 0.5. We're looking at the x direction alone. We're just moving in the x direction. Just anything else with y, just ignore that for now. Ignore y for now. All right? So we're in the x direction and our mass is 0.5, our velocity is 1. So our momentum is 0.5, right? That doesn't change. All right, it continues. it continues and it continues, right? And to continue this way until something happens, right?
Okay.
It's not affected by friction. It's just moving. It's not troubling anybody, right? It's not troubling anyone. The momentum doesn't change. The velocity doesn't change. Now, say we add this guy into the mix. Let's add this guy into the mix, right? So,
It's time now.
initial velocity. What initial momentum of one again?
Finna.
Nah, yeah, sir.
I'm
With
going
the
to
man, no,
my,
bro.
all right.
But with the man,
All right. All right, let's give it a try again. So what was the initial momentum for
bro, mute the mic.
one? The initial
Yes.
momentum for one was 0.5, right?
Yes, sir.
Right. Now if we have an accident happening here, say number 2 is going head on with number 1, right? Now we're not focusing on the momentum. You look here, what's the momentum for 2?
0.5. 1.5 to
1
1.0.
Oh,
1.0.
1.52.
approximately 1.
1.0.
Yeah, approximately 1. So the momentum for 2 is what? Greater or smaller than 1?
Smaller.
Greater.
Greater, because the momentum for 1 is 0.5 and the momentum for 2 is 1.
Sir, that means I would have faster, sir.
It would be, it has, but look at it, it has a slower velocity. The velocity for 0.7 is for 2 is 0.7. And
Because they have more inertia.
it have more, not really.
I mean,
It has more mass.
yeah, I mean,
It has more mass. Because this one has a mass of 0.5, but then the 2 has 1.5. That's a lot more mass. All right, so we're going to see, we're focusing on the momentum for 1 now. Let's look at the change in momentum after the collision, right? So let's go ahead. All right, now what is happening here?
Very get faster, sir.
Yeah, the
Increase.
momentum increase, but the mass does not change, right? The mass doesn't change, but the velocity increase because of that collision, right?
Because one smaller, sir.
Yeah, this one is smaller, so the smaller one now has a larger amount of
Excuse me, sir.
momentum. All right, go ahead. I hear a
That
question.
would cause the second bar to decrease speed, sir.
Right. It will also cause the second bar to decrease. Thank you so much for pointing out that. Remember that this momentum was at 1. And it drops, it went all the way down to negative 0.22. Right? It increased down, all the way down. So it was
Because
at 1.
because one can
One
generate
absorb the momentum for the
Right.
next.
Right. So,
because one can generate enough.
right. All right. So, what was the initial momentum for this again? This was 0.5, right?
Yes, sir.
Yeah, that's
This
it.
was 0.5. Now find our impulse. Remember that impulse is a change in momentum. So what would our impulse be?
From 0.5 to
0. I mean, for ball 1, sir.
Yeah, for ball 1. Let's focusing on ball 1 for now.
0.
Change the momentum. Remember, it was at 0.5 and now it changed to 0.775. Right? So we want to find a change, which will be the difference, which would use minus, right?
yes, sir.
Yeah, so find the difference. What is our difference in momentum or impulse?
0.5.
No.
Negative 0.2.
Yeah, but yeah, it's the same 0.27 thereabout.
Yes,
0.27. You don't have to put the negative there because we're focusing mainly on the difference. All right, but it is 0.2. All right, so we're understanding so far. You want me to do it over again or are we good?
Man,
Government.
All right.
This
Wait over, sir.
bro, every
Over
man,
one more time.
man,
Yes,
we have
sir.
English
This
today.
over.
Just come.
All right. Let's do it quickly once more. So I'll place this back at 0.5.
more than 0.5. Oh,
All right, 0.5. Right?
Yes, sir.
That's gonna be perfect. All right. Yeah. So we're only focusing on the momentum or the change in momentum for one. So for the person who just came in, what is our momentum? No. What is our momentum? No, it's not moving. Well, it will be moving. All right. Let's put this down here. Right. So what would our momentum be for one?
0.5, sir.
0.5, right? 0.5. And you realize nothing is bothering it, so momentum stays the same and the velocity stays the same, right? The
Yes,
velocity
sir.
doesn't change. Don't crash. Okay. All right. They get the point. You get the point. I'll put this back. 0.5. Let me remove this. This guy is giving us a trouble. Right. So we have it's moving, going from side to side, and it's not nothing is bothering it. So that proves our first Newton's first law. An object in motion will stay in motion, right? Unless we put a force on it, or we there's some form of collision, right?
Example of a car, you know.
Good
Yeah.
answer.
Right. So it will continue in motion just the same. And now we add our other object here, and let's not focus on the other object. Let's keep our focus on number one. So our current momentum is at 0.5, right?
Yes, sir.
0.5, and now our velocity is at 1. So our mass, remember that momentum is mass times velocity, right?
Yes, sir.
Our momentum is mass times velocity. Our mass is 0.5 times velocity 1, we would get 0.5 as our final momentum. Now we're going to have our collision, right? So let's play now and see what happens, right? So look on the momentum now. Momentum has changed. Why? Because of the why it
Collision.
changed? Because of the collision. So it was initially at 0.5 and it's now at 0.99, almost 1. So what is our change in momentum? It was at 0.5 and now it is at 0.99. How do you find the change in momentum?
4.
Subtract, sir.
Yeah, we would simply subtract. I won't be able to go over this again for the other person. I guess they're going to have to watch the video,
4.
right? Watch the video after the class. So we subtract 0.99.
0.4, I get 49.
Yeah, approximately 0.49.
I said 0.5. No?
Yeah, it's approximately 0.49, 0.5. So that is basically our change in momentum, which is our what's this word right here again?
Impulse.
The
Pause.
impulse. Right. That's just what I wanted to get. Right. I just wanted to be able to identify that impulse is a change in momentum. That is it. All right. So impulse can happen very quickly. Right? Impulse can happen. Realize in a collision it happens very quickly in the space of a second. Right? You have two objects coming together and just colliding, right, in the space of a second. And that change happens so quickly and it is so impacting because we have two large bodies coming together at full speed, right? And the momentum changes on both bodies. You will find that it's explosive, right? And it has a lot of force involved in it, and people can actually get hurt because of change in momentum, right? So therefore, momentum can be used to study collisions, collisions and explosions, right? Any form of collisions or explosion, we can use impulse to study these, right? Let's do this before we close and then come back, right? So we said that impulse is a change in momentum. So first we have our final momentum. Remember the last experiment, the final momentum was 1, right?
Yes, sir.
And then the initial momentum was what?
2.
Was that 0.5?
Yes, sir. 0.5.
Our
0.5.
last experiment, sir, what we just do.
The one that we just did. It was in the final was at 1, and then the initial was at 0.5. So our change in momentum.
Because it's 1 minute.
Yeah, we're gonna close and then come back. Right? Our change in momentum is 0.5. Right?
Yes,
That's
sir.
just what I want